Welcome to Longevity by Design, a podcast designed to give individuals access to the leading scientific information in the field of longevity. The ability to add years to your life and life to your years needs no opinion. Join us as we ask science to take the wheel. In each episode, Dr. Gil Blander joins a co-host and an industry expert in the field of longevity, shining a light and getting the answers to the key question: how can we live a longer, healthier life?
Hello, I'm Dr. Gil Blander. Welcome to Longevity by Design, How to Live a Longer, Better Life. We are produced by Inside Tracker, your science-based guide to optimize your body from the inside out. Our guests today are Dr. Leroy Hood and Dr. Nathan Price. Dr. Leroy Hood is a world-renowned scientist and recipient of the National Medal of Science in 2011. Dr. Hood co-founded the Institute of System Biology in 2000. Dr. Hood holds an MD and a PhD in biochemistry, and he and his colleagues developed 4 sequencer and synthesizer instruments that paved the way for the Human Genome Project, successful mapping and understanding of the human genome. Dr. Hood is currently carrying out studies on Alzheimer's disease, cancer, and wellness, and has played a role founding 15 biotechnology companies. He has co-authored textbooks in biochemistry, immunology, molecular biology, genetic, and system biology, in addition to having received 18 honorary degrees from prestigious universities in the US and around the world. Dr. Hood has published more than 850 peer-reviewed articles and currently holds 36 patents. Dr. Nathan Price is the Chief Scientific Officer of Thorne Health Tech and author of The Age of Scientific Wellness together with Dr. Hood. Previously, he was a CEO of Longevity, an AI health intelligence company that merged with Thorne in 2019. He is named as one of the 10 emerging leaders in health and medicine by the National Academy of Medicine. And in 2021, he was appointed to the board of the life science of the National Academy of Science, Engineering, and Medicine. He spent most of his career as a professor and associate director of the Institute for System Biology, and as a co-director was with biotechnology pioneer Dr. Leroy Hood of the Hood Price Lab for System Biomedicine. He has co-authored more than 200 peer-reviewed scientific publications and given over 200 talks and keynotes. Thank you for being here today.
Thanks, Gil. It's great to be with you.
Thank you. So as I said in the intro, before the intro, it's a great pleasure to have you have 2 leaders in the domain of scientific wellness, system biology, computational biology, AI, machine learning. And I would like to start from the beginning. And maybe each of you can explain to our audience what brought you to become a scientist, and how have you got interested in personalized medicine?
Sure. Yeah. So it's interesting because growing up, I didn't really know any scientists, and so I sometimes ask myself that question of how I got into this. I had a really wonderful grandmother who was a private school educator for many years, and her house burned down in California one year, kind of on a very unfortunate weekend between insurance coverages. And anyway, she ended up moving in with us when I was about 3. And it was interesting because I got very interested in the lives of scientists, and we would go through a number of books and stories, and just it somehow emerged as an interest of mine. As I got older, the books that probably had the biggest impact on me, like so many people in science, were those by Richard Feynman. So I read basically everything that he had written that was accessible to me at that point in time, and just became really interested in it. And it was interesting because I don't think I actually met someone who was professionally a scientist probably until college. And I remember doing a summer internship at the University of Washington, and it somehow dawned on me that a scientist wasn't just this amazing thing like someone like Richard Feynman was, but I could actually choose that as a career and follow it. And as I learned about how that process works and got interested in it, I just became hooked and wanted to go into it. So that was a lot of the path for me.
And the path for me was I grew up in Montana and went to middle school and high school in a very small town in north central Montana that had three of the best teachers I ever had. They, for the first time, treated me as an individual and made me realize that my joy of mathematics and science could actually end up leading to an appropriate career. And two things were really, I think, transformational. My grandfather actually built a summer camp for geologists from Princeton, Yale, Columbia, Harvard. And in fact, they came in the summers, brought their students. I worked there 3 summers and did some of the courses with them. And one of the projects I did there led to being one of the final 40 finalists in the Westinghouse Science Talent. So I had a chance to see scientists, how they worked, and then going back to Washington, saw really bright colleagues, my own age and everything. But I think what really set me up for the career I chose was my chemistry teacher had been a navigator during World War II and had gone to Caltech for a year and a half to learn appropriate mathematics and so forth for that. And he decided any good student he got, he would send to Caltech. And I'd never heard of Caltech and had reservations about wanting to go to a liberal arts school rather than the technical school. But in the end, I went to Caltech, and it prepared me superbly in math and physics and chemistry. And then I went to medical school and then came back to Caltech, and in thinking what I wanted to do, saw that I was most fascinated about the complexity of human beings and how can you begin to decipher that complexity.
Excellent, fascinating story. And again, I read it in your book, and I will recommend all of our audience to read that book. It's a fascinating book about how hopefully in the future we'll use wellness as more a scientific way to allow us to live better, longer. So I would like to start with the first topic of our discussion, and that's the past and future of healthcare. And specifically, I would like to discuss the problem in our current model and where you see healthcare going in the future.
You want to start again, Nathan?
Sure. So it's a really interesting if you step back and you look at where we're at in healthcare. So as we go through in the book, the genesis of what we call modern medicine really began with this report that was written by Abraham Flexner, who went around the country and he observed like a really sorry state of medicine. And if you think about those early times, this was, and there's really grim statistic, but it was an age in which every third coffin was filled with the body of a child who had died from an infectious disease. So we're getting killed by these things. This is the norm, right? You have a bunch of kids, they're not all going to live, and every parent basically goes through that. And so you fast forward with Abraham Flexner, he really brought science into medicine. It centered up this whole academic enterprise and joint research medicine enterprise that we have now. And if you look in the 20th century, it was remarkably successful. We don't die from the top 5 killers that used to kill us all the time. We barely think about them in certain parts of the world anymore. And so you fast forward and you say, okay, that was amazing. But now what we're kind of stuck in is because that was so successful, we ended up taking that same model that we used so successfully for the big killers in the 20th century, which was this find the pathogen, kill it. So this find it and fix it approach. You now go into the 21st century with all of our problems being primarily around chronic disease, and we mapped it into find the target, drug it. And we got this fairly unified approach to try to deal with chronic disease. And the problem is that we've organized now all of our medical and scientific enterprise around diseases, right? If you look at the National Institutes of Health, they're organized right around disease, this disease, that disease. And our interventions and even almost all of our scientific studies are done very late in those processes. And one of the big issues is that if you're very late down into chronic disease, it's really hard to reverse that. And it's really hard to think of a single molecule that's going to do that. And so as we started thinking more about the state of medicine today, it became clear that the challenges that were in front of us required a different paradigm where we would think about these issues much, much earlier and bring the same level of rigor to the study of wellness and how to extend life and extend health span and slow aging and all those things to the same level of rigor that we had spent so much time on the study of disease. And then the second big factor that's really changed is the technologies that are available to us now to be able to make lots of measurements, and it's getting more cost effective all the time, and the application of computational tools, including AI, and that's moving incredibly fast now, that let us get to this notion that we can be much more predictive, much more preventive, intervene much earlier. And so that's what really got us excited about this notion of what we call scientific wellness, which is basically like the approaches of things like precision medicine, but applied much, much earlier into the expansion of health. Lee?
And I'll go into just a little bit of detail of specifically what we hope to be able to do. So I would argue that this data-driven approach to health is one of the biggest revolutions in the last 2,000 years in our thinking about health. And it leads to a view of health that says each of us has a health trajectory, and that health trajectory has 3 different phases. We usually are born in a wellness phase, but sooner or later, all of us go through one or more transitions to disease. So I would say health really is those 3 factors. How do we optimize wellness? How do we reverse years before clinical diagnosis disease? And that's chronic diseases generally. And then how do we deal with disease itself? And the data-driven approach gives us very powerful avenues forward. For wellness, I would say the normal well person probably has reached 20 or 30% of his potential. And we now have actionable possibilities that have come out of the data-driven analysis of a large population of 5,000 people that let us, if acted upon, improve wellness and or avoid disease. In looking at these very early transitions that we see in the blood, we have a signal that says, let's reverse the disease at that point before it becomes more complicated. And we'll spend a lot of time doing that in the future. And the hope is that we can ameliorate a large fraction of chronic diseases in the future. And of course, the third, how to deal with disease, is what contemporary medicine is all about, except we're taking a global, a holistic approach toward disease, and realize that almost all chronic diseases are going to need to be multimodal in their therapeutic approaches and so forth. So the idea is that we started a company in 2015 that recruited over the next 4 years 5,000 patients. And we did this data-driven approach with each of these patients, doing a complete genome sequence and then blood analytes and the gut microbiome and digital health measurements and all of these. And putting all of these data together gave us beautiful statistical correlations that, when investigated in the literature, led to these actionable kind of possibilities. And we're now proposing that we go from 5,000 people to 1 million people in a program very much like the Second Genome Project, and do it over a period of 10 years with the government supporting, as it did in the initial Genome Project. And that'll allow us to do 2 things. One, unequivocally demonstrate the power of improving the quality of healthcare, and 2, demonstrating the enormous cost savings that'll come if we focus on wellness and prevention rather than on disease.
Excellent. Thank you so much. And actually, the 2 of you covered the 4 questions that I wanted to ask you, which is great. But I want to zoom in into a specific point. And Lee, I know that you really like the term scientific wellness. So I think that it's important for our audience to understand it, because wellness is now used by everyone in the street. And I think that your term of scientific wellness is a bit more defined. So I would love if you can define it. And then why should the healthcare system be wellness center? And how can you measure wellness?
Well, I think scientific wellness is really an important term because it implies with the data-driven approach that we have a quantitative systems approach to gathering data and coming to understand wellness, transitions, and disease. And in fact, for us, either scientific wellness or quantitative wellness, the two are more or less synonymous one with another, but they infer that we go well beyond just thinking about diet and exercise and sleep and stress and things like that. In fact, what's really interesting about this data-driven approach we're taking to health is not only does it generate actionable possibilities that arise from your genome, from your phenome, but we get actionable possibilities that are derived from integrating all these different data types together. And this is created a whole new field of mathematics that takes the data, does the integrations, and then maps them into the biological networks that underlie the physiology of wellness and the physiology of disease as well. And I think in the future, the reason we feel these actionable possibilities are so important is that, one, they allow you to explore the full potential of your wellness. They give us a chance to detect disease before it appears clinically and reverse it. And hence, we can focus entirely on wellness and prevention in the future, and much less we can diminish enormously the focus on disease that today is 95, 98% of what the healthcare system does. But the important thing is not only do we generate data, we use that data with a systems thinking and approaches to map it into the basic biological networks that underlie what we are as human beings. And these networks give us insights into brain health, into body health, and into the health of your gut microbiome, the three major areas that seamlessly integrate together to make a whole human being.
Excellent. Thank you so much for the explanation. And earlier in the discussion, Nathan, you discussed a bit AI and show us how excited you are about it and how it is the future. So can you explain to our audience the source of your excitement and what do you think can we do with AI in the near future?
Yeah, certainly. I'm happy to. And in fact, we just, Lee and I just published an article in the Wall Street Journal today on AI and healthcare, which is an excerpt from the book if people are interested in checking that out. So the revolution that AI is generating now is clearly massive, right? Many people are. It's the fastest, ChatGPT was the fastest growing technology in human history. So it's not like that's news to any of us. So the issue, though, that arises is as you look at the amount of data that it's now possible to generate about your body, there's no way that it can fit into the standard model of something that a physician could remember or have in their head, right? If you go back a few decades, your physician was an expert in a certain topic, kind of knows everything that's going on in that topic area. Now, if you're trying to personalize responses based on genomics alone, no way in the world that you would be able to even get anyone's mind wrapped around all of those elements without the interface of computation. So when we look at the capabilities that AI is now bringing to us, for one, it really democratizes access to information. So information delivery is very straightforward now. And in fact, information delivery was already made quite ubiquitous just by the fact of the internet and technologies. But now you have personalized intelligence that you can deliver. So, for example, you can imagine portals into the scientific literature. And I'll just give the caveats to start with that, there's all kinds of accuracy issues we can get into and things that need to be sorted out. But I'm just going to give the positive view for a second, assuming we get those things sorted. So if you look at that, you can go into the literature, and rather than even having to find a paper, you can ask a question that says, I really want to know what do we know about the connections between these lifestyle choices, the exact ones you're thinking about, or the exact products you're thinking of taking, or the exact situation you're in, and write me an article about what's known about that pulls from information from hundreds of thousands of papers. Like that is now a technology that is real, which I think, it wasn't even on the radar, a blip for most of us, certainly, a few years ago. And more than that, you can pitch it at a level. And you've probably done this, all of us are playing with GPT, where you can ask, like, treat me like I'm a PhD scientist that knows a lot about this issue and write the article. Or it might be something I don't know anything about. Treat me as a well-educated layperson that doesn't know anything. Or, write this at a level that my 13-year-old can understand, or whatever. So the ability to drive information that is gathered at scale, that is processed and contextualized to your situation, is now hugely democratized. So the ability for us to think about delivering healthcare that is more proactive, that is more personalized, and that is much cheaper is made very possible by doing that. And it's not just, at the level of these information passages, but also in terms of what we can learn off of data, which is getting so much dramatically better. And there's already studies that show, even with the very earliest forms of this, that doctors that are empowered with these kind of technologies, they can help avoid mistakes. They can let the doctor focus on the most important parts. And the other aspect that makes the doctor so essential is that we do know that there are errors that AIs make. Not everything's in the AI. They have no model of causality yet, right? They don't know what's going on in the real world. They can make terrible decisions. But if you're a physician who is empowered by those kind of technologies together, your job changes, but the scope of what you can do becomes much, much larger. So anyway, that's a few ideas, but we could go on for a long, long time, obviously, on the implications of AI in healthcare.
Absolutely. Thank you so much for that. That's definitely the future, in my opinion, as well. And I would like now to switch gear and discuss the Pioneer 100 study that you done. And in your book, you have at least a chapter on that. So if you can discuss it for our listener, what health metrics were you looking at? What were the outcomes of this initiative and so on?
Well, I can get started on that. Nathan and I worked together at the Institute for Systems Biology, and in 2012, 2013, we're beginning to think about how we could apply some of the systems thinking to normal populations. And we came to the conclusion that a terrific trial would be to take approximately 100 individuals and do this data-rich analysis where we analyzed completely their genomes. And as well, we looked at we quantified 500 proteins in the blood and 1,000 metabolites and probably 150 clinical chemistries. And then we looked at the gut microbiome and we used the Fitbit. So we generated the genome data, which is static, obviously, and the phenome data, which can continuously transition across the 3 time points in a year we took for these analyses. And I would say the really striking conclusions that we came to was confirmed the importance of systems thinking. Namely, there were enormous and fascinating interrelationships among the 6 different types of data types we could analyze, genetic variants in the metabolites and the clinical chemistries and the gut microbiome and proteins and so forth. And that these statistical correlations indicated elements that were interrelated that could then be taken back to the natural literature to see if there were actionable possibilities that could be derived from their associations. And over the course of the first year or so, we were able to generate probably 50 to 75 actionable possibilities that could be used to, again, improve wellness and or let one avoid disease. And we could give specific examples of this. But I think what was interesting and really indicative of the times is prior to the onset of that study in 2014, I did go back to the National Institutes of Health and talk with leaders back there about the possibility of getting funding for such a precision population health program, as we call it now. And the NIH leader there that we talked to laughed and said, "Don't be silly. NIH is only interested in disease. We would never fund anything in wellness," which made us go back and have to raise the money from philanthropy. And later we raised the money to start the company Arivale that went on to look at not 100, but to look at 5,000 different individuals. But the bottom line was it led to a clear concept of scientific wellness. It led to many different actionable possibilities. And we used coaches in order to deliver these actionable possibilities that were very effective in persuading the participants to actually carry them out. And we definitely showed striking improvements in blood chemistries and a variety of other kinds of features that we could measure. So the 100 Pioneer Project, I think, was an enormously successful project. I'll say one other thing that really illustrates the power of having a lot of features to be able to measure was in the initial study we did, we looked at 500 different proteins. At a later time, we came back from the same samples. We looked at 5,000 proteins, and we went from 3,500 statistical associations to 35,000 statistical associations with 10 times as many proteins. So, and what this did is it recruited in a larger number of networks and interrelated those networks more effectively to one another. In a sense, the data let us begin recreating the informational systems that underpinned wellness and disease.
So, Lee, one clarification question for our audience. Can you define the term phenome and explain what is that?
Sure. The phenome is your appearance across time. So you go from a baby to a young boy to a teenager to an adult and to an older. Those are phenomes at different times. And in a sense, your phenome is continuously changing. And you have, in a sense, an infinite number of phenomes across your life. What we can do for phenomics is to measure the three elements that come together to give you your phenome at a given point in time. It's your genome, it's your behavior, and it's your environment. Those are the three fundamental things. And we can measure those by looking at proteins in the blood, metabolites in the blood, lipids in the blood, clinical chemistries in the blood. We can measure them by looking at your gut microbiome. We can measure them by using a Fitbit to assess your activity and quality of sleep and all of those different kinds of things. So what we're attempting to do as we move forward with this large program is increase enormously the number of phenomic measurements while driving down the cost of phenomic measurements. And we think one of the really important aspects of the Human Phenome Initiative I described earlier is, just as with the Human Genome Project, we hope it will drive the cost of phenomic measurements down by many orders of magnitude. The human genome drove the cost of DNA sequencing over a subsequent 20-year period down by 6 or 7 orders of magnitude. So we think the same will happen for phenomics as well.
Excellent. Thank you so much. And my follow-up question for that is, how did this data of the 100 pioneer led you to start the personalized wellness company, Arivale?
Sure. So when we did the Pioneer 100, we were really excited about the kind of information that we could see. And we knew that it would go up tremendously if we could get to larger numbers of people. For the reasons that Lee mentioned before, we also became convinced that this wasn't going to be something that would be funded in kind of the general course of scientific grants to NIH or things of that nature. And so we really wanted to scale this up in a way that it would make a difference for people's lives. And so as we thought about that, we really became convinced that we needed to start a company, and that the only way that you would really be able to generate the kind of major longitudinal data from a wellness state would be through giving people an experience that was worth it to them, right? That they would be able to that we'd be able to make a difference to their health today and tomorrow and in the, right now, such that they would stay with us. And then as a byproduct, you create these data clouds that allow you to do an incredible amount of learning. And we'll talk about that in a little bit. And so that's what really got us excited. And we met some wonderful people along the way, Clayton Lewis, who ended up being the CEO of the company, Sean Bell, and Jennifer Lovejoy, Sandy Kaplan, who was the first big wellness coach, et cetera. So they're just all these people that were coming together in this and helping to drive that forward. And so what turned out to be actually a really great program for people in it turned out to be hard to convey or educate people about what this actually was. But we ran that program and it ended up bringing in about 5,000 people over a 4-year period. And we learned an incredible amount from that, which I'm sure we'll get into.
Yeah. So what you learned from the rise and fall of that company, and also you mentioned 5,000 users or clients. Why only that and not much more? What didn't work in the process?
Yeah. So I think the big challenge early on was that it was relatively expensive, and the value proposition was a little bit soft. So I think the difficulty of bringing people in were they didn't really know what scientific wellness was. And especially early on, it was something like a $4,000 cost for the program. That was not an inflated cost, but by the time you do the genome and the other measures, that was, at that point in time, that was pretty much at cost or even a little bit less. So that was certainly an issue. And I think, so it was the cost of the assays, which have come down a lot. And then it was the education process of what this was, because it had this really strange dichotomy, which was when we did surveys of satisfaction of people that went through the Arivale program, they were extremely high and our retention rates were really high. But our cost of acquisition, our CAC, our cost of acquiring a customer was massive. And so it was just hard to kind of convey to somebody what they were going to get out of this at that point in time. And the other fact that I'll just say is we were not connected into healthcare systems, so we didn't have a good way to hand off this information to their doctor. And the regulations were even more stringent then than they are now. And so we could know a lot of things that we're not allowed to do anything about or give to anyone because that wasn't plugged into the traditional healthcare system. So those elements made it challenging to really provide the value. And then the other element was just we were a lot less far along than we are now. As we start talking about what we've learned through this process, the number of things that we can say, and they're all in the book, about health today compared to where we were 5 years ago before we had the chance to analyze the data is just night and day. It's just radically better now in terms of how much more this is understood. And I think that's why, some of the newer efforts and other companies and such that we, drive forward now are much bigger scale.
Yeah, I just want to say that at Insert Tracker, we took a bit different direction, which less deep, going less deep into the data and having less coverage, but having much more eyeballs, I would say. And today we are around 100,000 users. So again, we don't have thousands of analytes, but we have tens or hundreds of thousands of humans with similar data, but again, not as deep as you have. And I think that it's a different approach. Apparently, our is still working because we're still around and we are flourishing. But I think that definitely scientifically wise, your approach is the right one. Collect as much data as possible, but it's not always doable in the real life. So I completely appreciate and I understand that.
And you're obviously right from the. Oh, sorry. I was just going to say you're obviously right from the commercial standpoint. In terms of Arivale didn't make it, but the flip side is on the data and the learning. We still publish results on those data continuously. The amount we learn, like this past week, we had a big paper in Nature Medicine, which of course one of the top journals in the world, hard to get into, and it's a reanalysis of what it means to look at a very common metric of BMI. But it says but what this data showed was that if you did a biological BMI based on this kind of deep dive, and you characterize individuals' metabolic health in this way, that you could in fact be much more predictive about what was going to happen in their health than you could from a traditional BMI measure. It was much more connected to the microbiome, much more flexible, a much better, much more useful measure that you could in fact deploy into medicine, which is why Nature Medicine published it, and how hard it is to get papers into those journals. And we'll get into a whole host of others, but we still off that data set, and despite it being, as you say, commercially relatively small at 5,000, it's still in the, certainly in the academic realm, that's still constituted by far the largest, really deeply phenotyped population in the world, the first one that was really done that way. And so what it opened was just a huge number of discoveries about related to the health of the microbiome, related to biological aging, related to refactoring BMI, all these different elements that we could get into in more detail. And I think that data set, even, was early and we have to solve different issues commercially now. It was a absolutely central corner piece of understanding how these things fit together and what you could in fact learn from these that makes it so much easier to do that today.
Yeah, I completely agree with you. And by the way, it's a very tough domain. It's very tough to be the person that started a domain, and there are a lot of coaches around. So it's definitely a great achievement to receive 5,000 human being with so deep data. So I'm completely with you. I would like to shift gear and talk about biological aging or biological age, and why it's so important for a lifelong wellness. And I would like to start, my first question is, aging is the number one factor for every major chronic disease that we know. And my question is, and I'm sure that you heard David Sinclair saying that aging should be a disease and so on. So I would like to know what is the two of your opinion about it. Is it a disease or isn't it a disease?
Well, I think my own viewpoint is, in the sense you can look at it as a disease. In the sense it's an accumulation of negative factors that lead your body to become less efficient. And in the sense that we can circumvent, we can slow or even reverse those things, that's you're treating it as a disease. But again, I think that's where the Arivale population really showed itself beautifully, because we had individuals in the 5,000 that ranged from 21 to in their 90s. And we were able to show beautifully that as you aged, your ability to confine the expression of your blood analytes diminished enormously and they become broader and wider. And from that, we could actually develop an algorithm for biological age, the age your body says you are, as opposed to your birthday. And the biological age, of course, the further it is below your chronologic age, the better you're aging, quite obviously. And we showed one when we looked at sick people in the Arivale population, and we had various diseases, 40 or so of them. Every single one of the people in those diseases had a biological age above their chronologic age. And with diabetes, it was an average 6 years. And two, if you took the upper 5% of the Fitbit contestants, the ones that did the most exercise in there, their biological age averaged 2 to 3 years younger than their chronologic age. And so we think that biological age is a wonderful metric for wellness, and it's a wonderful metric for assessing your own aging. And the important part of our metric is, rather than using epigenetic markers on DNA to do the calculation, we use metabolites. And the reason the metabolites are important is they let you actually determine the biological age of various of your organs, your liver, your kidney, your immune organ, your metabolic health, and so forth. And the metabolites and their deficiencies or excesses can actually give each individual unique possibilities for optimizing their aging process. And we think that's a very important part of the biological age as measured by blood elements and things like that. We do agree that because aging is the major factor on most chronic diseases, anything one can do to decrease the rate of biological aging extends the time period before one gets into chronic disease. Or maybe with scientific wellness, it eliminates the factors that cause transitions into chronic diseases. So aging, I think, is really an important metric for assessing and optimizing both scientific wellness and the healthy aging process itself.
Excellent answer, Lee. And again, you packed a lot of information inside your answer, so I want to unpack it just for a normal audience that are not as smart and brilliant like you are. So I want to start with about biological aging. And specifically, there are a lot of ways to measure biological age. Steve Horvath came with the epigenetic age. You have glycan age, you have the proteomics, you have the blood base, and I assume that there are some about telomeres and so on. So I would like to know your opinion, and maybe Nathan, if you want, you can take it. What is in your opinion, the best way to measure biological aging, and maybe why?
Yeah, so there's certainly different ways to think about this. So for me, the way that I most like to make biological age measurements today, and the way that we in fact implemented it, is through blood measures. And so the reason that I like that, and these are like around clinical labs today, and the reason that I like that is because in studies so far, if you're looking at biological age, not just as a something that you're trying to predict your age from, but does the difference in your biological age predict whether or not you will go on to have more chronic disease in the future? And the studies that I've looked into and the things that we've done, I believe that today the biological age that's most associated with those health outcomes that you care about are those that are based on clinical labs. So that's my preferred method today. Now, that said, I'm not at all against in any way the evaluation of biological age on every other omics data. So, and I think that they have the potential to continue to get better. So Metabolites, as Lee mentioned, I think are a really interesting source. Epigenetics are a very interesting source, because they relate to, a lot of, potentially fundamental mechanisms, and especially as we learn to interpret them more. You do glycation, right? As you mentioned, very interesting. Telomeres are interesting. But to me, the metrics that I care about when I look at biological age are, is it actionable? Is there something that I can tell somebody to do that's specific and measurable? And then is it predictive of them going on to have improved health? And so I love all of them scientifically from the standpoint of being able to watch them. And then from an implementation, I just want to know, is there something I can say from it that will really make a difference? And of course, these are all getting better all the time. And the one other thing I'll say is that a biological age is only one of what we would call a class of metrics for wellness. And I love the whole notion of don't just tell a person if they have a disease or they don't have a disease, but say something fundamental about biological processes that are happening in their body and how can they make them better? How can you be more resilient? How can you be younger next year than you were this year? And just to back up on that slightly, I like the definition of aging that is just, what are the odds that you're going to die in a given year? Aging is essentially that number ticks up a lot as you get older. And if we could figure out how to keep that flat or just flatter, that would have a bigger impact on health span than anything you could do. It would be better than curing any single disease by far. So it's a massive problem.
Yeah, I'm 100% agree with you on the what you said about the biological age and the blood and the fact that there is direct association with disease, and that's basically what we are trying to prevent. So 100% with you. I think that it's a great explanation, maybe the best that I have so far. So thank you so much for that, Nathan. And the next question, and again, I'm going a baby step, because I think that it's important for the audience to understand it. It's a pretty complex subject, especially not to a trained scientist like us, is what is the value of knowing your biological age? Why is it important? Why should they do that? Think about a consumer that want to do it. Why should they do it?
Well, I would say biological age is important because it gives you an index as to how well you're proceeding in your health trajectory with regard to the aging and with regard to scientific wellness. And it's always useful, I think, in arguing for wellness and for diminishing your scientific aging, to have solid metrics that you can show an individual and say, look, in this 4-year period, your biological age has gone, compared to your chronologic age, has gone down 5 years or 10 years or whatever. We saw one individual, it was actually Nathan, in the Arivale population, have his biological age go down 10 years relative to his chronologic age. And, that raises really interesting questions of what can we do with the aging process? Can we just slow it? Can we reverse it? Can we actually control the slope for aging in the future and really prevent you from moving into stages where you have chronic disease, especially if you buttress your biological age with the many different actionable possibilities that come from scientific wellness. So I think its greatest value is it gives the individual a sense that they're really making progress in improving wellness and diminishing aging and holding off all of those chronic diseases that most of us run into at a later period in our lives.
And I would just add one little thing to that. I agree with everything Lee said. And it's just such an easy measure for people to have their heads wrapped around. So if you tell an average person, like, your hemoglobin A1C is 6.5%. Okay. Now, those of us on the call will know that, higher than 5.9% is bad. That's a bad number. But the average person has to remember that. And what's the number for LDL and what's the number for HDL and what's the number, but it's so easy to know, hey, if my biological age went down 2 years, that's a good year. That's an amazing year. So, it's a very simple, so it has that aspect in addition to, all the deep science elements of just being something that's so easy to understand.
The one thing I would add to it too, we did the calculations for males and females in Arivale for the 4-year period about what happened to their biological age. And the biological age for women went down 1.5 years per year. And for men, it went down 0.8 years per year. So it was striking testimony to the success of all the things that Arivale did to improve the wellness of individuals.
Yeah, absolutely. My next question is, again, you mentioned, Nathan, you mentioned that in your opinion, the blood is the best way to measure a biological age, and I agree with you. And I actually used to call blood a liquid gold because it's literally, in my opinion, is maybe worth more than a gold, and I assume that you agree with that. Can you elaborate a bit about that and why blood is so important, why blood biomarkers are so crucial and important for a person to measure during his lifetime?
Sure. So the blood is just a remarkable source of information. Every one of us, of course, your blood is bathing all the organs of your body continuously. Your cells and tissues are secreting molecules into the blood. They're taking molecules out of the blood. And the amount of information that's in even just a small amount of blood is staggering. And the ability that we have now to monitor those kinds of data is remarkable. And so there's a lot of development that's happening, and everyone can probably think of a very famous example that failed for reasons on trying to miniaturize some of these measures. But when you look at the omics technologies, like metabolomics, proteomics, genetics, epigenetics, all these things, we, as scientists, we only ever measure those on very small amounts of sample. That's what they're designed for. That's how they're only ever measured. And so this unlocks for us the ability to go into a small amount of blood. And this can even be on, you can even get this, right at your home. And you can get that information and leverage it to have tens of thousands and even more measurements that are being aggregated into health. And I was having a really interesting discussion yesterday with former head of one of the largest health companies in the world. And, and we were discussing this and how, there's so many measures that we do in healthcare today that we do because that was a technology that existed 20, 30 years ago when we set it up. It's not really the way we would think about doing it now. And so as we think about harnessing all this information in blood with these new technologies, which we're really just working through regulatory processes and so forth for how these all get deployed, it is going to give us orders of magnitude more information about our health in the coming years than we've ever had before. And so the blood is, and you can get it from saliva, stool is super important for microbiome, but the blood is really the heart of where you'll get the most information.
And I would just add to that, we view blood as a window into health and disease. And one of the really exciting ideas that's emerged in the last 10 years is each organ has proteins that are specific to that organ that can be secreted into the blood. Once you identify those organ-specific proteins in the blood, their quantification gives you an idea of the health of that particular organ. And we've now identified organ-specific blood proteins for 25 different organs. So in a sense, the blood gives you a status for your entire organ system through the measurement. The brain has literally hundreds of brain-specific proteins, probably thousands actually. Very few get secreted into the blood unless you have a disease that affects the blood-brain barrier. And then that disease gets reported by the fact the number of brain-specific proteins from the regions where the barrier has been compromised go way up and everything. So the this idea of blood as a window, I think, is one of the fundamental ideas that our whole view of what health and wellness has been based on. And the idea is the smaller we can make the sample collection sizes and still give us all the information we want, then it opens, as Nathan hinted at, the idea that we can begin blood collections at home and do everything we need and just send it in and get these reports and their data analyzed to the doctors and in turn goes back to you. In a way, we, in a sense, will have a tricorder type instrument in the future that makes the measurements you need to assess your health throughout the entire body, for the brain, for the body, and for the gut microbiome as well.
So, Gil, if there's a chance, there's actually one more point I'd love to make that's around the blood, but it's really about the power of pulling together multiple data types. And I just want to talk about one of the discoveries that we made, again, off of this, population that we did from Arivale. So just consider a very common marker like LDL cholesterol. Millions of people are on statins. We monitor LDL cholesterol, super common, and everyone knows about it. So one of the questions we asked was, should everyone be treated the same given the same LDL level that they have? And so one element that's very interesting is that you can use genetics. So you can take a genomic signature and you can predict the level of LDL cholesterol in a person's body. And at the time we did our study, you could capture about 11% of the variance. In just the last few years, you can now capture over 20. So these things are getting better all the time. But just even on that early signal. Now, 11% may not sound like much, but that's enough of a gap to move someone from being below clinical range to being above clinical range. And so when we were taking people through a lifestyle program, we just asked the question, who was able to lower their LDL cholesterol by lifestyle? And some people could and some people couldn't. That's what the literature says, that it's kind of a mixed bag. But then we applied this genetic test, and it turned out you could predict who would lower their LDL cholesterol by lifestyle and who wouldn't by genetics. And the key variable is the delta, the gap. So if your genome predicts your LDL cholesterol is low and you're high, you can lower it by lifestyle. But if your genome predicts you high and you're high, it's very hard to change it. In fact, we saw no statistically significant power in the top 40% of people to be able to do that, while the bottom 40% could. And then it was the same was true for raising HDL cholesterol. It's also true for hemoglobin A1C and so forth. But the one point I want to make is that introduces an entirely new category of variable across all of healthcare, which is not just what are your blood biomarkers, but what are your blood biomarkers in relation to the genetic prediction for your level. And so today we just look at those versus some rough population averages. And we do not have to do that that way in the future because of genetics. So if you take genetics coupled with the blood measures, this now much deeper, much more actionable than either alone. And when you start layering in microbiome and all these other kind of things, it just gets deeper, 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 as you know very well. But I just wanted to make that point because I think it's Nathan,
let me make one more point added to that, and that is recently we have the ability to look at 150 different disease genetic risks through their polygenic scores if you have your whole genome sequence. And my prediction is for virtually every one of those disease phenotypes, you'll treat low-risk people differently than you'll treat high-risk people. And I think the combination of genetics and blood metabolites is going to be absolutely one of the key things for optimizing health and generating new kinds of actionable possibilities.
Yeah. One clarification, polygenetic score is basically a score that you take, you combine a lot of single nucleotide polymorphism and make one score. And as Nathan said, for example, for LDL cholesterol, I assume that there are hundreds of those single nucleotide S&P that combine together to get into those 20%. This is a relatively new technology. And by the way, we are using it right now at Instant Tracker, and we have like 70 of those that help us exactly what you said, Nathan, to not only to look at it compare myself to the population, but also compare myself to myself and see what is my risk, or what are the cards that I received when I'm going to play the casino. Right. Are they a great card or a bad card? And it's so important. And the healthcare today is not using it. And I definitely read the paper that you published in a scientific report a few years ago. And that was, I think that it was the first example of doing something like that for wellness. So absolutely amazing discovery.
I'm so glad you saw that, because it was one of those papers that we thought was really a remarkable discovery. And that paper released the week that Arivale went out of business, which totally swamped it. It's like totally swamped it out. And I'm like, oh, we just finally figured out some things that are super actionable here. So we're trying to get that. But the one thing I wanted, just for your listeners on polygenic scores, one of the things that I find so remarkable there, just to get a handle on it, is the case of height, right? We all know that height is inherited because tall parents have tall kids, and we can see that, and that's pretty clear. But for many years, it was this conundrum in genetics, as you well know, that no one could find a gene for height, or even a small number of genes for height. But if you fast forward to now that we've done these huge genomic studies on millions of people, that now it turns out that height is the most predictable factor of all polygenic scores. But how many variants did it take to do that? It's over 180,000 that contribute into prediction of height. So it's highly genetically conserved, but it's massively distributed what matters. So it's just, so your listeners get a little bit of a sense, like that field is moving, but as it gets better and better, the insights that you get are so much deeper as you connect it to the dynamic data. Anyway, we can move on to a different.
No. I think that it's a great a segue to AI, because you're starting to talk about, you said height and more than 100,000 different single nucleotide polymorphism. Definitely, even the smartest person in the world cannot calculate 100,000. So can you, maybe you, Nathan, discuss a bit the AI and the role that AI is going to play or playing now in the wellness revolution?
Yeah, for sure. So exactly like we were just talking about on those genetic signatures, right? 180,000 variants. You can't possibly keep that in your head. And that's for one simple trait. There are, of course, hundreds or thousands of different traits that you might monitor genetically. Then there's all the dynamics of what's changing over time. And there are differences in interpreting a lot of these biomarkers. They might change during the time of day, for example. And so that matters. So this wealth of information that you have to take into account to really do diagnosis and prevention and in a precise way is staggering. But the beautiful thing these days is that you don't have to keep all of those things in your head. Of course, those things can be done in algorithms, and they can surface to you or to the practitioner or to the individual, depending on the nature of the problem, insights in the moment that they're most relevant. And so the complexity that comes along with thinking about these areas of scientific wellness or systems medicine, if it's getting downstream, those complexities, it's really on us, those of us that are doing, the research, but then also doing companies and providing products and all these things. That complexity has to be absorbed into the AIs, into the delivery, because what we give to people has to be simple and actionable, that they can do something in their life that it makes a difference. So the onus is really on taking that massive complexity internally, dealing with it, making it visible. So if people want to dive in on the why, they can find the why. And it's really important that this is clear box and not black box. But it has to deal with that in such a way that you can just have that impact in a simple way on a person's life. And that's really the essence of everything that we have to do to make scientific wellness a reality in the world.
And continue with that. And by the way, the chapter about AI and machine learning in the book, it was my favorite chapter. It was my favorite because I learned a lot from that. And I think that the two of you gave the best explanation about the two different AIs. So I want to discuss it a bit and ask you a question about it, because there are, based on your explanation, there are two kinds of AI. One is more like based on the processing speed. So basically, you gave the example of a Deep Blue versus Garry Kasparov, and how at the end, it won because it had more processing speed. So at the end of the day, it can look at all the possibilities and then beat a human because we cannot weigh all the possibilities all the time. But the second one, for me, it's more interesting. It's basically domain knowledge base or expert system base, and how that will combine with some machine learning. Actually, that's in my opinion, that's going to be the future, because you explain it also in the book very well that it will be very hard to come to a position and say, hey, here there is a cancer or there is a tumor, but you need to explain the physician or to the user why you believe that there is a tumor. And basically machine learning is a black box, but the expert system is more open and explain the way. So can you discuss that a bit? I think that's a very important point from the book.
Yeah, I'm happy to get into that. I think that, we kind of divided in the book into, there's these data-driven approaches, which are really driven by really large-scale processing power and correlations and so forth. And they are highly dominant in the world today, especially with ChatGPT and the explosion that we've had. And I'll come back to that in a moment. It's been really amazing. Then there was this other thought process around trying to represent more the way that humans think about things with causality. And this led to expert systems, which have been used for a long time, but they've had these really big problems that they just don't scale the same way. And so you end up with this dichotomy, and we've got the world sort of racing forward, especially in this data-driven approach. So I think what really comes down to is, what do we mean by understanding causality? And, Judea Pearl wrote a beautiful book called The Book of Why that goes into, how correlations are, some of the things that we find from correlations, he likes to say data are profoundly dumb. So even though we can do pretty amazing things with them, they're not asking causal questions. So if we fast forward into what we're thinking about here in medicine, there is this really interesting space that's emerging now, because if you look at things like, the GPT or these large language models, they are still based on, massive statistical correlation, right? Prediction of the next word, or now prediction of huge windows of words. But they approximate some elements of causality because the text is derived from what humans say, and humans have a model of causality. But it is important that that language model does not, in fact, have a model of causality. When it says the word cat, it doesn't know that that's a physical, that exists in the world and what a cat is. It's never interfaced with it, and so forth. And so where there is this nexus that's going to be so interesting in the future of AI is whether or not you can take, what we call knowledge-based AI and data-driven AI and somehow get these data-driven systems to also interface with something that we might think of as knowledge, which might be built more around, causal pictures of what the world has to behave like. And there are people that will argue that you can get to everything through correlation. There are people who argue it's impossible to do so. And, so you get into these really interesting debates. But it is going to be really essential. And we talk about all this in the Wall Street Journal piece today. But it is really essential that the AIs are able to explain why they're doing things. And today that's incredibly important, because too often that why is terrible. Right? There's the early AIs, there's great examples of this, right? They ran this AI across this whole EHR system, and they got 99+% accuracy on being able to say, how do you not die of heart disease? Oh, that's amazing. What was the answer? You ingest carcinogens. So that's like not, you'll die of cancer. You're not going to die of heart disease. So, so there are all these elements that an AI might spit out that are bad. Or there's this really great result in radiology where they, was predicting cancers with super high accuracy. But what was one of the features when you were able to clear box it? It turns out that when pathologists look at a cancer, if it's big, they pull out a ruler to measure it. And so the ruler is in the picture. And so when AIs were getting this hugely highly, accurate measures. Part of it was because if they saw a ruler, they knew it was very likely a tumor, because the guy wouldn't have pulled, the physician, she might not have pulled it out if she were doing the measure. And so all of those kind of things come into play. So it's a really fascinating time for figuring out what are the incredible powers of AI, but what also are the limitations, and making sure that it is interpretable back to us, at least for a while, is really important.
I would add just one thing to that. And I think this whole question of whether you can make AI have domain expertise such that when you feed the patient's data in, the AI can actually look at the gaps and the inappropriate elevations and levels and all those things and come to a concise, direct, precise prediction of what exactly you have to do for that patient. And we're actually thinking about being able to educate GTP-like systems by putting in very large knowledge graphs, by using digital twins that have assembled the data for things like wellness or for type 2 diabetes, two things we're assembling digital twins for, and to put in all of PubMed with its errors, but with the enormous information. And the interesting information is, can you then put a patient's data in such a way that the educated AI can actually make causal rather than statistical inferences? And there's a big argument as to whether that's going to be possible. My gut feeling is it absolutely is going to be possible in the future. But it'll be fascinating to see where we are in 10 or 15 years.
Excellent. And Lee, you mentioned digital twins. So can you elaborate for our audience, what is digital twin?
The digital twin is essentially making the model of something that's very complicated. And the classic example is you can do a digital twin of an airplane that mimics digitally the entire airplane. And you can do experiments on the digital twin that will faithfully reproduce what is going to happen to the airplane at a future time. What we want our digital twins to do is to reproducibly and accurately assess the alternative health trajectories an individual has at their point in time going forward, and then pick the optimal kind of trajectory. And for digital twins in biology, the top-down things you feed are any differential equations that tell us about, say, how diabetes works, or the physiology that we know about diabetes. And the bottom up is the biochemistry and the omics and the clinical chemistries and so forth. And then into that, you feed the individual's data. And the thing about a digital twin is it continuously improves as more and more data goes into the digital twin. And then if you can use so educated digital twins on this hyperscale AI to educate it, we might be in a very different position than we are today. That is, to have it be causal in its inferences rather than statistical.
Excellent. Thank you so much. Another point or a chapter that I really like in the book is related to deep monitoring or monitoring our body a lot and collecting a lot of data in order for us to know ourselves better. And there you mentioned that a key, and I'm quoting for the book, is making the invisible visible. So can you elaborate a bit about that? I think that's a key part of the book, and I would love to hear your thought about that.
Yeah, I would say that just relates a lot to what we were talking about with blood measures and things of that nature. Because as you're going around and living your life, our bodies obviously have certain sensors. We know when we're tired, we know when we're hungry, there's all kinds of things. But we don't necessarily know when there are plaques that are building up on the inside of our arteries, which can be life-threatening. We don't necessarily know if our, hemoglobin A1C is ticking up. Is our insulin resistance really getting bad? Is our ability to deal with oxidative stress getting worse? Is our ability to deal with osmotic stress getting worse? Or is our level of antioxidants depleted? Is our, et cetera, et cetera, et cetera. There's all these things that we don't have any sensors that are available to our conscious minds externally in our bodies alone. And so by taking these measurements, right, and making, the genome is invisible to us, right? You get it sequenced, now it's visible, right? All these elements in your blood that you don't know about, they're invisible to you. You're making it visible. And I think that there's a real power in not just knowing something generically, but in seeing this is happening in my body right now. And there are things that I can do to make it better, and I can retest and I can see that. And so it's just bringing things that we know are important to the foreground so that they're visible to us that I think is really key.
The other point I'd like to make too, and that is to stress what's true of the body, and Nathan has just described that, is even more true of the brain. Right now, medicine ignores the brain and its health to a first approximation. And yet, as we talk about in a chapter in the book, there are very good digital measurements for assessing, for example, 25 different cognitive features, and not only assessing them, but essentially being able to reconstitute lost cognitive functions. And Michael Merzenich, who pioneered this whole field, demonstrated even in 80-year-olds, your brain is plastic and you have enormous reconstitutive powers for regaining lost cognitive functions and so forth. So we really want to stress how important it is to make the invisible visible and promote people to exercise your brain, just exactly like you exercise your heart, to have it be healthy. And look, if there's one organ you'd really like to be healthy, it ought to be your brain.
Yeah, absolutely. Going back to the question about the invisible visible, there is a risk that we will make it too visible and then we see too much data and then we will confuse them. So how would you, in other way, provide to them the meaningful and not the meaningless? What is the way to do that, in your opinion?
I think the way to do it is to use the data to get actionable possibilities that validate in a quantized fashion improvement in wellness and or avoidance of disease. And it's true, the body is infinitely complicated. We may never understand the fundamental biochemical meaning of consciousness and things like that. But that aside, there are so many things that we can take on in smaller bite-sized pieces and promote activities that exercise and make healthy the brain, the body, or the gut in varying ways.
Yeah, I think part of the goal of the analyses is what's the 1 to 3 most important things you could do for your health today? And then give people a chance to action on those, right? And come back. And then what's the 1 to 3 most important things you can do for your health at that stage? And just continue that process, because you can't get too overwhelmed by how many of these things there are. And it also relates back to what we were talking about with, the genetics and blood markers and so forth, because you can highlight not only the things that would make the most difference for your health, but also the things that are most likely to be responsive to your efforts. And you can put those things together and say, here are 3 things that would make a huge difference in your health, and likely your body will work with you rather than against you, i.e. you'll probably reach that. And you can just give people so much more guidance about what's the next best thing to focus on, because you can't do it all at once.
Yeah, I completely agree with you. And I think that it's a good segue for my last question. Again, I have a lot of questions to ask you, but unfortunately we are starting to run out of time. So we usually ask our guests one question about what is your top tip for improving health span for our audience. So Lee, maybe we'll start with you.
Okay, I can tell you unequivocally, I think in my own experience, the thing that's made the most difference in my health span is vigorous exercise. I've done it all my life. I did technical rock climbing when I was younger and climbed El Cap and did things like that. And I've always felt subconsciously that exercise really just enriched and enabled and invigorated me. And, I think actually there's a partial, simple explanation for exercise, and that is it really oxygenates your brain. And your brain is an organ you can never get enough oxygen to. And if you have regular episodes where you do hyperoxygenate it, I think it's really great for the brain. And that's obviously good to think about regarding neurodegenerative diseases as well. But I guess the second thing I would say is semi-fasting. That is eating in a narrow window of time. And for example, I eat dinner and then don't eat again until a late lunch. And so you just eat in that 6 or 8 period of time. And I think having the proper weight is something that I put very much akin to the exercise. So for those things, you don't need very sophisticated data analysis, I will admit.
Yeah. When I interviewed David Katz a year ago, he said that it's like the 80-20. So using a sophisticated tool like Arivale or Wilson Tracker, giving you the 20%, but the 80% is exactly what you said. Be lean, exercise, and eat well. Luckily, we have a lot of people that want to go to receive the 20% on top, but most of the population will receive a lot of value from doing what you are doing. So I would 100% agree with you. Nathan, what is your tip?
Yeah, so I'll go to the 20% because there's no doubt about what table stakes are. But we also all know of people that have done all those table stakes things that still, very tragically get cancer when they're young, or they get, there's these issues that arise. So the piece that I'll add here is to the extent you can, I would take ownership over having detailed measurements from your body and health that you can track longitudinally to know where you're at, what's happening, and so that you can be aware of when your body undergoes transitions. And so this would be, monitoring in the blood, get your genomics done in whatever form you want to, periodically measure your microbiome, and, and work with, with groups or companies that will help you so that you can have that data monitored longitudinally. And then be smart about personalizing the approaches to what are the factors that are the most important for you to improve your health and give you the greatest chance of that long healthy life. So I think that's the piece that I would add on top of, the table stakes that we all know are the foundations of a long healthy life.
Excellent. So thank you so much, Lee and Nathan. And we look forward to exploring the research in the field of longevity each month with you and leading scientists. For more information, please go to www.instaltracker.com/podcast.
Thanks for listening to Longevity by Design. Please subscribe to this podcast on Apple, Spotify, or YouTube. Longevity by Design is powered by Inside Tracker, a personalized health optimization platform that helps people improve their lives by improving their bodies from the inside out using personalized, science-backed recommendations for nutrition, supplements, and lifestyle changes. To learn more, visit insidetracker.com/podcast.